sorry, not the volume, the pressure didn't change.
Okay.
But I thought there was one where it was just T and V, but maybe
Uh,
there's
is
oh
it the?
there it is, Charles law. Yes, sorry.
Oh,
So
okay.
it's more simple than this. We don't need to use this.
Okay.
It's that V1 or V initial over T initial equals V final over T final. So the subscripts are just meant to represent before and after, or sometime before, sometime later.
Got it.
So we've got 4.2 over 355 equals V final, which is what we're trying to find, over 435.
And then you just cross multiply.
You can yeah, normally you would do it. You can actually just shortcut it here a little bit. You just multiply both sides by 435 like this. And so your V final is 435 over 355
Okay.
times 4.2.
Got it.
And grab your calculator. It shouldn't be like like notice how the 355 went up to 435 by to say 20%. The number's gonna be like 20% bigger. It's not gonna
Okay.
be like 5,000. It's gonna be like 5.
5.14.
Yes. Yes. So 5.14
Okay.
liters.
Okay. Perfect. That wasn't bad.
No, not too bad at all. So the next problem here, let me grab it from the chat. I think the next one does use the pressure stuff.
Okay.
There's 3 equations, I think. There's one for these, pressure, temperature, volume. I don't know.
P1 V1 equals P2 V2.
That's one of them. Yep. All right, so let me get this question framed right. All right, scuba driver with a lung capacity of 5 liters. So that's the volume initial is 5 liters, inhales a lungful of air at a depth of 35 meters and a pressure P0 of 4.9 atmospheres. If the
Okay.
diver were to ascend to the surface where the pressure is, so P final is 1.0 atmospheres, what volume would the air in her lungs expand? So this is the danger of rising too quickly in scuba diving. I've never
Yeah.
done it, but I've only heard about it. It is a great way to cause yourself a lot of pain and suffering. So don't ever do that. Follow the instructions.
Yeah.
But yeah, it's a you said P1 V1 equals P2 V2, I think.
Yes.
And that's exactly what we have here. Now, if you
Um,
want to be like, okay, well, it's 1 and 1, 2 and 2, totally fine. Okay.
okay.
So your pressure one, 4.9, your volume one is 5, equals pressure 2, which is 1 atmospheres, V2, that's what we're trying to find.
Okay. So 5 times 4.9, which is 24.5.
Liters. And that's a big expansion. That would be very dangerous to do.
Yeah.
Okay. Now, have you been receiving full credit on your answers in these? Because we can kind of like add a little wrapper of words if you want around it, but
Um,
I mean,
no.
this is it. There's not much more here. This
No,
is
yeah, that's fine. That was easy. That was literally just equations. Okay.
yes,
That was fine.
and the pressure, temperature laws. They're very straightforward.
Okay, perfect. All right, well, we're done with that.
So, quiz next. Is that
Yes.
yeah, let's take a look here. If I could find it. Boy, that's not good. All right, there it is. Download. No, I don't want to replace it. Call it lesson 7. No, no. All right. Ooh, this didn't. So I
Yeah.
only got 1 page of this. We
Oh,
might want to do the print to PDF when you choose your
oh
printer.
yeah, okay.
But I can work with what's here for the first view if you want to do that in the background.
Yeah, okay.
Um, Well, number one is a pure definition, and I have no idea. These all seem true. Gases are moving, particles are moving around rapidly. They're very far apart. But I have no idea why that you can compress more than, so I'm just gonna go out to the internet on this one. See if something makes sense here.
Okay. If not, I can just look at my notes.
Yes. So it's something to do with the kinetic molecular theory of gases, which I don't know. Let's see here. So I'm seeing it's the reason they can compress more is that they are very far apart.
Or okay.
And I guess that makes sense. If there's a lot of room between something, it's like when you're packing, you start compressing things down, you get more stuff in the box.
Okay.
So that's kind of my best
Oh
guess
yeah.
of
Yeah,
that.
that's what it says. Gas particles
Perfect.
are very far apart.
Some of the stuff is very intuitive. It's just when we wrap it in chemistry, we think, oh, it can't be the same, but it I hate saying should, but it should be in this case. All
Mm-hmm.
right, so we just did a problem like this.
Yep.
What is the final pressure based on this? So it's P1 V1 equals P2 V2.
Okay.
Pressure started out at 1.2.
Um,
V1 is 1. We
okay.
don't know the final pressure, but the final volume is 4.
Okay. So 1.2. So 1.2 and then equals. Do you just do 4 divided by 1.2?
You got to divide on the left side there. 1.2 divided by 4.
Oh, okay. Which is 0.3. Yay. This one's just one that I can find, so don't worry about that one. Mm. Is this the equation? Wait, I can't hear you. Are you talking?
I apologize. I do that from time to time.
Oh,
Where I
no, you're
mute
good.
myself. I mute myself because I'm looking up stuff. I'm drinking some water.
Oh,
I want
you're
to be
fine. You're
so
fine.
so there are 760 millimeters of mercury in one atom. Well, there's nothing worse than hearing someone chew or something
Yeah.
worse. But I try to get it in and then unmute real quick.
Oh,
But
you're
this is the conversion, and it's expected that you know this or know where to find it.
okay. Okay. Perfect. So
So go ahead and you're going to divide, take 435 and divide it by 760.
perfect, which is 0.57.
Got
There.
it.
Perfect. These aren't that bad. These are literally just like equations.
Yes.
The one before the bonding, whatever, that was horrible. I literally
Yeah.
sat and I'm just like, I give up. Like, I don't know.
Yeah. Sometimes you just say, well, I'll use my kind of exception on that one, or
I'm just
hope
like,
for the
yeah,
best.
whatever. I'm probably never gonna use this, and if I do, I guess I'll just have to figure it out eventually.
Yeah. So this is one of those, like, I know you could look it up. It's very intuitive, right? The heater is used to heat 1,400 liters of air in a hot air balloon. So hot air balloon, you got the basket, we're all having a good time hanging out. But if there's a reason that person is still forcing hot air into the balloon, and
Mhm.
because if you don't, the balloon's volume decreases,
Yeah.
and
Yeah.
then it crashes and it's horrible. We don't want that. So that's why there's someone in there constantly pushing hot air back into the balloon, keeping it up. And so if the heater is turned off, well, the volume is going to go down.
Yeah. Okay. That makes sense.
All right. So number 6. All right, a sample of argon gas has a volume 750 milliliters at a pressure of 1.1 atmospheres and a temperature of 109 degrees. What is the volume of the gas in milliliters when the pressure and temperature of the gas are changed to 15.1 atmospheres and minus 14 degrees C? So we were looking at an equation earlier. I think it was P1 V1 over T1
Yeah.
equals P2 V2 over T2. Now I
What's
haven't
P?
focused.
Oh, the temperature.
Yes. Now,
Okay.
we've got to be careful because I believe the temperature needs to be in Kelvin, but I'm not 100% sure.
Okay. Yeah.
So
That's
we might
what.
as well just the conversion to Kelvin is really very simple. It's temperature in Celsius plus 273.
Yeah.
So it's this 109 plus 273 gives you 382 for your T and T1. And then your T2 is minus 14 plus 273, which is 259 T2.
Okay. So then P1 would be 1.0. Or wait.
1.1. Yep.
Okay. And then 715 for the volume
Yep.
over, yeah, that. And then P2 is 15.1 and 109. Oh wait, no,
We
sorry.
we don't know we're
Oh
trying to
yeah, we
find
don't
the
know the
volume.
other one. Okay.
Yeah. So the way to proceed from here is to figure out this number on the left, whatever that is, figure out this division on the right.
Okay.
And so you're going to have some number times V2 equals some number on the left, and then you're going
Okay.
to divide both sides.
786.5 on the top
Okay.
over 382. And then uh you just cross multiply, right?
Well, why don't you, yeah, just keep it simple here. This isn't a math class. Just divide this and give me the answer like 4 decimal places.
Okay. 15 point 0.1385.
Okay, and do the same thing over here. Just divide this and get it to, you know, 2 decimal places or something.
Okay, 2.058.
Roughly.
Yes.
Okay, now you're going to divide both sides by 0.1385.
14.80. Oh. Hmm. Oh, maybe we don't change it to kelvins. Or maybe we do.
Right, I found it. So you saw me
Okay.
just correct this. I just need to, I muted myself just to figure it out. 259 down here in the bottom. For some reason, I just used 109, which is really bad. So that changes this number on the right, but it will give you the correct answer. So why don't you
Oh,
recalculate 15.1 over 259?
okay. Wait, 15.1 divided by what? Oh,
259, 259, yeah,
that is gonna be 0.058.
like this, and then divide both sides by that.
Sorry, 2.05 divided by 0.058, 35.34.
That does sync up with this one right here.
Perfect.
Okay, so we can move on to the next one here, next numerical one.
Yeah. This is just
Uh,
the one, is it? I just looked it up. 1 mole of any substance is the 6.02 times 10 to the 23rd.
that's if you're going to molecules. So liter, it's
Oh,
so the conversion is 2.5. You start with the moles N2 times, in 1 mole there are 22.4 liters, which is
oh,
it's a known conversion. There's nothing hidden.
oh,
That's an accepted value.
okay.
What you're referring to is Avogadro's number, which does
Yeah,
sometimes work, but not in this problem.
okay. 22.4 times 56 liters.
Yeah, there you go. Good.
And then the next one,
This is another one of those pressure, temperature, volume potentially. So you give
V1.
me
Oh,
P1, but is there, it's a P, it's a pressure and temperature. Um, so what's the relationship with pressure and temperature? There's one more. I think we did it earlier. Is it P over T? No,
E-
V over T, P1, V1. Okay, so we can use the fact that the volume does not change to go P1 V1 over T1 equals P2 V2 over T2. But since volume does not change, they just cancel. And it becomes P1 over T1 equals
oh,
P2 over T2. So just
okay.
like the previous problem, you've got all the numbers, but we do want to convert those um, to Kelvin. So that's
89 plus,
89 plus 273 is your T1.
which is 362.
P2 is 116 plus 273.
That's 389.
Okay, so now got to just add the numbers. Put the numbers in the equation. So P1 is 3.3,
Okay.
T1 362. We're trying to find P2 over 389.
So 0.009 equals, so do we cross multiply? I feel like it's just easier for me to like think about it like that.
Yes, do it the way that you know how to do it, rather
Okay.
than trying to go to a way that isn't going to help you if I'm not around. So you're not going to offend me. The goal is for you to get this right, get through the course, all that stuff.
So 1,287. Okay. 3.54. Perfect. So 0.7 and 0.7 times 25, which is 17.5. $17.5 divided by 2, 8.75, so 8.8. Perfect. And moles of gas particles. What's
All right.
taurine?
Okay. So I'm sorry. So the answer to 10 is the amount. Amount
Okay.
is because it's not volume, it's not temperature, it's not pressure. An amount refers to the number of moles,
Okay.
but it's like amount. Amounts where like
Got it.
it's too broad.
Okay.
But anyway, so core is just another unit of measure. So you're looking for the number of core to go to millimeters of mercury. And this is again where you go out to Google or your notes from the class, and
Mhm.
you look for the conversion, and it's exactly 1.
Oh. So
I don't
just
know why.
less. 3.
Yep.
Oh, perfect.
Okay. That's 11.
The higher
Well,
the atmosphere pressure is, higher, or the pressure is low.
so I believe the pressure increases as you go up, and
Yeah.
I believe it's because there's more particles exerting pressure, but um, I would just double check that.
The amount
If
of gas molecules in the air decreases. So
no, it's less particles.
yeah.
Maybe, or no, maybe,
It
I don't
said
know.
as altitude increases, the amount of gas molecules in the air decreases. The air becomes less dense than air near to the sea level.
But what does that mean for pressure? Like I
Thin
always think of,
air exerts less pressure than
okay,
air
so
out.
it's actually lower because there's less particles is what I just heard from
Oh,
you.
okay.
And I'm just gonna just do another search on the internet, see if I can find a thumbs up answered on this one. Decreases as you go higher, and there's less. Okay. Yeah, I think that does it for that.
Okay.
I don't see any reason to make a change. All right. 13 is another one of these, pressure volume calculations.
Okay.
All right. So they tell you the air in a 5-liter tank. So V1 is 5.5 liters. P1 is 1.35 atmospheres. What is the new pressure, V2, when the air is in the place? V2 equals 8.5 liters.
Okay, so P it's just multiply 1.5,
Yep.
1.35 times 5.5, 7.425, and then divide by 8.5,
Okay.
0.87.
There you go.
Yay.
Right.
And
Yeah.
then 14 is just when using temperature, the units must be in Kelvin.
Yes.
Okay. And the last one. Can you give me 1 sec? I need to grab a
Sure.
tissue.
Sure.
Okay. I'll be back in 1 sec. Okay, I'm back.
All right. So this is what I mean, I wish this question was first because we really needed to know this to kind of do all the other problems. But it's important. It has to be in Kelvin. Um, it's like driving on the right side of the road. We just, that's what we do.
Yeah,
So, all right, number 15.
yeah,
All right, a rigid container. So again, another one of these things where they're giving you some combination of pressure, temperature, and volume. The T1 is 40 degrees C, but we know we need to add it to 273 to get
yeah,
to Kelvin.
which
And
is 313.
313, and then P1 is 4.55 atmospheres. T2 is 55, but we need to add it to 273.
Which is 328.
328. P2 is the unknown. That's what we're trying to find. So it was, and because the volume is held constant, it's another one of those P1 V1 over T1s equals
Uh-huh.
P2 V2 over T2s. But because the volumes are the same,
They cross out.
they go away. Yeah, they go bye-bye. So it's
Okay,
just P1 over T1 equals P2 over T2.
okay. 4.55 divided by 313.014. And then the other one is, oh, and then you cross multiply. Wait, what did I have to write that down? What did I say?
I didn't catch it. What about P2 over 328 here?
Oh, okay. Okay. Wait, 4.55. Wait, I did that wrong. Four point 7.6. Oh, there.
Could be a little bit bigger than what,
4.77.
yeah, just like the little bit bigger than the original number. Yeah, good. Do you feel like you can do
Okay.
these on your own? Couple of equations, P1 V1,
Yeah.
P2 V2.
No, yeah, these make sense.
Great.
These do make sense.
We did not answer, I don't know, maybe question 3. I'm happy to go back and
Oh,
look at
yeah.
that with you if you need, or maybe you've already looked it up.
The
It's a definition. I have no idea. I was just gonna help you find the answer.
Okay, yeah, I'm just gonna find the answer and then I'm gonna submit it. The total pressure in a mixture gas is equal to the, okay. Socratic, let's see.
So I'm seeing a thumbs up on the partial pressure, which they don't have here. Okay, equal to partial pressure of all the gases added together. So I'm seeing,
Total,
I'm seeing, I'm
oh,
seeing
okay,
that.
yes. I think that's,
And this has got some thumbs up on it. on what I'm
Okay.
seeing on.
Okay, perfect. Yay.
All right, good job.
Okay.
Is there
Yay,
anything
100%.
anything else to help you with today?
I don't think so. I think that was it.
Sure.